Yes, good afternoon. I'm going to demonstrate a small solution I made to do parallel work in APL. Basically, it's inspired from, let's perhaps just look at the agenda first. Very little about the company I work in, and then I will present the idea. And then lots of demonstrations, so lots of live demonstrations, so fingers crossed. And hopefully time for some questions at the end. So, just a little about SimCorp, company founded more than 50 years ago, and very, very recently taken over by a German company, Deutsche Börse. I think it's translated to German stock market. And we develop systems for investment management and have SimCorp Dimension and Sofia, because we bought APL Italiana at some point, and we have a few others. We are about 2,500 employees worldwide, and 29 offices. We have 2.6 million lines of APL code and running in SimCorp Dimension as is. I have to say that we are not real APLers. We do trad fonts. We have structures, even for while loops and stuff like that. So. We are terrible at APL. SimCorp Italiana is much better. They are real APLers. We also have many millions lines of C# code. Okay, the idea came from the fact that we are trying to move our product, SimCorp Dimension, into the cloud. This is what you do these days. I presented it 3-4 years ago, what we were planning to do, and now we are doing it, and still doing it. So we decided to make a completely new entry point platform for running our product, SimCorp Dimension, and that should be made in C# and be made very web friendly from the beginning, and it must be multi tenant and session and user and what have we. Because we have a lot of APL code already in our system, 30 years of IP, we cannot just throw it away or redo it in C#. So of course we wanted to still be able to run the APL applications. So we decided very early in the process that okay, we will just lift what we have already and try to put some nice interface on top of it and see if we still can use the APL functionality we have. So each user will have its own hosted APL session that very much contains the same things as they do today in the old client two-tier setup. So, but based on this work we have done, I think, okay, I want to share some of this with you, follow APLers. And could I take the gist of how we do this and make a very simple solution that could actually be shared with you? Then it could be fun also for myself to understand it better, what we are actually doing. But the key word here and what this session is about hosted APL. So I'll explain what this is about. So today we are running in the two-tier world. We start up in Dyalog X and load a workspace and do some bootstrapping, and here we go. But that's not really an option in the cloud. So as said, we decided to wrap it into a C# thingy. And inside that C# process, we'll run our APL, and we can run multiple APL sessions. Maybe you, I don't know, you can see I marked the exe. So this is a good old Dyalog exe, but doing it this way, we are using a DLL version of the interpreter, but basically it's exactly the same, just compiled as a DLL library. So what was the idea for this presentation and this solution I made? But you guys, you are working in an APL session, a good old APL session, but sometimes you have some task you would like to put out in other places, and especially you would like to do this in parallel to run different parts of the code in parallel, especially using all the nice cores you have on your computer, which you do not do in a single APL session. So what I did was to make a solution using this concept of hosted APL. So this solution is basically the glue you can communicate from your main APL session and ask the solution to give you some worker bees. I call it worker bees because basically it does the same as the isolate workspace does. So I had to invent a new name to pretend that it actually does something else. But basically the idea and what it can is the same as you can do with the isolate workspace. But we have the solution that binds these worlds together. And all of this is running inside one process, which is not the case with the isolate. I will show you later on. I don't know if it's important whether you run in one process or not, but it's just a fact. Some disclaimers that in SimCorp we don't use APL as you presented usually. So having to work with this native standard Dyalog IDE has been quite a fun experience. So bear with me if I do silly stuff. This is mostly a C# solution. There's also some APL. We'll come back to that later, and it very much built on the async await pattern. So of course it's good thing if you know a little about it, but otherwise I can definitely suggest you to look at the presentation John Daintree did a year ago in Portugal. You can find the videos on the website. And it's also worth mentioning, this is just a template. It's not a fully functional, there's no error handling whatsoever. So it's just to show you the bits and pieces needed for building such a solution. Yes. So first I want to show you what a hosted APL assembly thingy looks like, what it is and how you build it. So today you can take a class and if you decorate it with a few statements, you can see it's using system, it smells like .NET. You can make a signature that tells what type is it. It's a type string, .NET string. So with these decorations, you actually tell the compiler, that I will show you in a second, how to interpret this in a .NET typed world. So I have this very stupid little class that can have a constructor and it can say what you ask it to say. So there's an option of exporting such a thing as a .NET assembly DLL. So I say save, and you can you, by the way, see it? Not everything I can enlarge, but hopefully you can see the APL things, otherwise screen. And here it tells how it compiled the APL class into .NET, and that it created a DLL. Show it in .peak. Yeah. So here we have my hello class. It has a default constructor, but I also have this constructor I've made that takes a string, and it has a method, a public method say, that returns a string. Okay. So now I will go and export it again. And this time I will tick this one, enable multi-host support. Yes, I want to. And yeah, it succeeded. And and then I will go and look at .peak again. Just have to update. So what you can see here, hopefully some of you at least, that besides the constructor I made, it added a new constructor taking a so-called Dyalog interpreter typed second parameter. So this is what the process is doing, adding this extra parameter to all constructors. So if you have more constructors, it would do it with all of them. And this Dyalog interpreter resides inside the bridge under the Dyalog namespace. So I can make my hello class, and it can say hi, and I create a instance of the Dyalog interpreter and put that on as a second parameter, because now my constructor takes 2 parameters. I would say don't do this at home because it's far too simple, but just to explain what it's all about. Because when you instantiate the Dyalog interpreter, you should add some parameters to make it behave. But this is very basically what it's all about. So let's go to the next one. So now I will actually show you the solution. The very first thing I do is just to make sure that I point at where I have my solution DLLs placed, and then I can call a function. This is a workspace I made, and I will show you later on where you can get it, all of it. So there's a simple function, get bees. I can call it with a 0, and then it gives you, I really hate this talking. No one. When you give it a 0, it gives you as many calls as you have. So yeah, looking at my machine, you can see I have 12 calls. I get 12 bees, 1 per call. That's great. And yeah, a little confession. I don't steal. I'm lazy. So I wanted a function that does something, but not just the delay function doesn't really do something. It just takes time, but you cannot see it do something. And of course, you can make a loop function that loops around for some time. But inspired from JD's talk last year, I said, okay, the screens thingy is a nice thing. And it basically does, it counts, if you give it, like here, 5, it makes a 5 by 5 chessboard, and see how many places you can place the queen without they endangering each other. So there are 2 solutions here. Okay, so this is a nice function. Now I'll try with it 12 by 12, and as you can see, it takes some time. Great. So now I have my function, and I have my bees. But the bees are just empty APL sessions, workspaces. There's nothing in it. But I will take this queens function and fix it in all the workspaces. The one means that it succeeded to fix it. So great. Let's just get some idea of how long time it takes. An hour ago it only took 800 milliseconds. But yeah, so and let's try to ask the same question to one of the bees. And this looks terrible, but we'll get back to that. So what you can see from these figures is that the first time I actually used this session, I was standing in, and it took 1.5 seconds. Here you can see it actually didn't use much time here, so the time is spent somewhere else, namely in the bee. That is a separate APL workspace. But we don't want to wait. The whole point is to run this asynchronously. And we can do a lot of stuff in parallel and use all the calls. So this is, of course, what we are aiming for. And here is it where it comes in, the disclaimer about, I will not explain all about the async await pattern, but watch the video. But the point is, this is a naming convention, so if you have a function called async, it will return back to you a task. So I have things that do it right away, and I have the async versions of some of the functions. So I still only work on the first B. You can see it says done right away. You can ask the task, is it completed? Yeah, it's completed, and you can ask the result from the task. So the task is a .NET thingy. It's basically a .NET task you have at hand. So now let's run it on all the bees, and you can see it's returns right away, and when you want the result, it takes some time. But the interesting thing, what we want to achieve, you can see it actually worked on all the calls. So, ta-da! So yeah, what's new in this? Because you could do this with what we already have in the isolate workspace. I don't know if any of you have used that or use that in your daily business, but as you can see here, it spawns up a lot of processes. So what does the WorkerBees do? Yeah, it's a bit tricky, and for some reason, actually, I don't know if it's still impossible to get rid of this concept of copying the DLLs. But this is basically the interpreter DLL that is copied each time you spawn up a hosted APL. It takes a copy of this because it needs its own file. And I know that John H. we have struggled trying to find another way to do it. But it works fine. So here you can see we actually have these 12 interpreters that is copied while I created the bees. Yeah. So. And this is not a competition between isolate and this solution. It's just to show that basically they do the same in more or less the same time. There should be other reasons. Usually the isolate is faster, but and yeah, this is not nice. This is not very APL-ish way of expressing things. So I think I made my very first, again by stealing. What happened to?
Your editor's dot on top of the session. Oh, there it is.
Yeah, I took this parallel each and made it my own. My goodness. And it's just running using the same get bees and fix the function and do it basically in the same way as isolate will do it. This is a cold start, so it takes some time, and you can see now it spawns up 12 more bees. Yeah, I think. And time-wise, oh my god. So, yes. This is .NET objects. You have to dispose them. These are the bees that are used. Yeah, it was supposed to clean up all of them, but it doesn't do. I don't know. It worked at home. This is typical. And if we look at the isolates, resetting here will remove all the processes. Okay, but these until now it has been just black box. These APL hosted. What kind of beasts are they? How can we actually interact? So let's make another bee and let's fix a function and then call the function. Oh, stupid me. Of course, you cannot call it with a text. So, but it pops up. So this is actually the WorkerBees session. I can assign something to it and continue, and you can see that it comes back to the session here. You can also set a breakpoint and call it with something, and it breaks here, and you can say, oh, everything is fine, and you continue. And now you cannot really do anything with this session. It's not responding. It's just waiting for the next thing to do. I dispose it, and you can see it disappears. Okay. So, how to get it? So this is this solution, and I will show it in a second. It's uploaded to Morten Kronberg's Deliver APL repo in GitHub, and it's a subfolder called WorkerBees. There's a README. Tell you how to actually download it, what you need to do to get it up and running. And it requires that you have a Visual Studio to be able to compile it. Maybe it could also, probably it could also be compiled with a Visual Code, but I haven't tried it out. Probably have to tweak it a bit. But basically, it should be possible. I mean, this is not something that my company gets anything out of. So this is a spare time project, 5 minutes. So yeah, you can see it here. And there's also this workspace I have used. It's also there, so you can start to play around with it, hopefully, very fast. Okay, so the solution, here it is. Very simple solution. It consists of 2 projects, APL classes and WorkerBees manager. APL classes, this is where we have the APL glue code. So there's a WorkerBee class. Here we have the fix function and what have we. All the functions needed. Not that many, but you can add whatever you like. And maybe, I don't know if you saw it, but if you have the Dyalog installed, you can actually ask it to use the Dyalog editor. So it's quite nice to make APL code in the Dyalog editor. And now we come to the C# code. It, of course, uses a C# editor. And again, very basic, simple factory method where you have the get bees. Okay, if 0, then take processors. And then add new APL sessions. So as we saw, it is APL objects you get. And we are not going to look into the code, but the very basic thing is that we're using a single task scheduler, because it's important that we always call the APL bees, worker bees, on the same thread as they were created. This is a convention. We have decided to basically speed up things so you don't have to spend time on thread switching and stuff like that. So, yeah. I don't even understand all of this, because this single task scheduler, I would not have a chance to make this myself. But I think actually Marco did this. Many of you know Marco. But it builds on a .NET thingy called a task scheduler, and then we just specialized it a bit. And so basically, it's a queue. You put something, a task on the queue, and it gets executed and return the result. So that's basically the glue in it. One last thing I at least need to show you. APL inside Visual Studio, and what do we do about it? But as you saw, we could compile it into a .NET assembly, and this is what Visual Studio usually do if you work with C# or .NET languages, of course. But here you can actually go and build this beast. You cannot, because I think I will not have time to show the rest. I have actually could show the shared code files, but yes, I don't have time. Sorry, but that was actually a very important point. Sorry about that. This is a command line version of the compiler, so we can actually just call it as a post-build event. So it builds APL code here inside the same solution. So you can see it's compiling classes. And so yeah.
Thank you, Stig. Very good.